cold outside. I cannot open the windows. I have pre-existing conditions. How do you start to parse this all out for people? And you know, what kind of environment might it be? And this is subjective, admittedly, but what kind of environment would it be if the teachers were teaching feel unsafe? I think it's going to be different district to district, and that's what the CDC is going to have to take into account in their recommendations. We heard what Dr. Walensky said. She doesn't think vaccinations are a prerequisite. So what are the prerequisites? And school districts can't meet those prerequisites in terms of ventilation, in terms of space, in terms of masking. Then what? Can they only open them with vaccines? I think these are the questions that hopefully we're going to get some answers on over the next week. It's critically important. Yeah. Yeah, the way that we need it in our kids.
Yeah. Are you there?
Yes, I'm here. I'm not really hearing your voice.
Yeah, I guess
Oh, let me. Can you hear me now?
Yes, I can hear you.
Can you hear me now?
Yes, I can hear you.
What question was it that we were hearing?
Let me check. So are you there?
Yeah, I'm here.
Yes, hold on. You were in number 29.
It's November.
Mm.
Let's go.
Let me open the picture. She said, which of the following formula cannot be an empirical formula?
Okay.
I put G. Because,
Eva.
yes,
So why is this the answer? Which of the following formula cannot be
I put D because
an
the
empirical
empirical
formula?
formulas are meant to be
Yeah.
broken into simpler ratios. But this
They're meant
one,
to be what?
they are meant to be taken, they are meant to be divided to the simplest ratio. If you do the empirical formula for all of them, you find C in A,
Yeah.
C is H, C is 1, H is 1.
Okay.
C,
Are you
C
seeing my
is
screen?
1, H is 2.
Are you seeing my screen?
Yes, I'm seeing it.
Okay.
I can see it.
Okay, please come again. Sorry.
I said that empirical formula is breaking down of the formulas to the simplest ratio.
Yeah. So why is D the answer?
And the empirical formula,
Because
the first element is meant to be smaller than the second one, but in this case,
yeah, B is the answer because this ratio 2:4 can still be broken down into 1:2. Have you?
yes,
So it's it's not the empirical because it's not the simplest ratio. But 2:5 can no longer be broken down into whole number again, lesser than this. 1:2 cannot be broken down. This can also not be broken down 1:1. But here 2:4, if you divide through by 2, you can still get 1:2. So that makes D the answer. Are you together?
Yes, I am.
Okay.
I'm coming.
You go out.
Sir?
So let's do the next one.
Yes, sir.
Okay.
It said line number 30 now.
Okay.
Hello.
Yes, I can hear you.
One of the criteria for confirming the purity of benzene is to determine its boiling point. So did you hear me?
Huh? Your network is not very strong. I can't hear you very well. So the question says, one of the criteria for confirming the purity of benzene is to determine its what? In test for purity, there are three major criteria, or three major criteria rather. I told you that this is one
I
of
said,
the.
did you hear me? I said one of the criteria.
Okay, your network is not strong. Your voice is breaking. But the three major criteria for confirming for test for purity, we have boiling point. The boiling point should be exact. The melting point should be exact. Talk about the spot on chromatography. So other ways of checking the purity is by, for a crystalline object, the crystalline structure has to be almost perfect. It should be the way it should. Then the specific gravity too should be exact. So try and log back in. I can't hear you very well, so that we can continue.
Are you there? So I said the answer was the boiling point.
Say, are you back?
So did you hear me? I said the answer is the boiling point.
Yeah, Chika, are you back? Can you hear me? Hello, Chika, can you hear me?
This is the answer.
Yes, sir. I've been saying that the answer is the boiling.
Chika, are you there?
Yes, I'm here.
Yeah, so let's continue, please.
So I said the answer is the boiling point. Boiling.
Yeah, it's boiling point because these are the criteria: boiling point, melting point, refractive index, crystalline structure, and specific gravity. These are the criteria for determining the purity of an organic compound. So you're okay on that. So let's move forward. Let's go to the next question. Are you there?
Hello.
Yeah, can you
Yes,
go on?
I can hear you.
Let's go on.
And number 31. When chlorine is passed through a sample of water, the H3 of the water would be sir. I put A because chlorine is acidic. It's not a base. Sir, did you hear?
Yeah, it's gonna get a little bit acidic. And acidic solutions
Yes.
they
They are
have
less than 7.
more than 7.
They are less than 7, so it will be A.
You're very correct. I don't know what's wrong with
Yes,
your
sir.
volume is actually breaking. I hear you then after some time, so I can't hear you.
My,
Your voice,
sorry, sir. I don't know why. Sorry, sir. I don't know why it's breaking.
I think it's network actually.
Let me
Okay, so
try.
what actually happens is that when chlorine dissolves in water, you understand, what is formed
So,
is the mixture of acids. And acids always have pH less than 7. You have to take note. Acids have pH less than 7, whereas bases have pH greater than 7. So the pH is actually less than 7 because
yes.
acid is formed
And when it's
when
neutral, it's equals to 7.
or if it's just pH of 7, then you're clear on that part.
It is equals to 7.
Let's read the next question. Let's be faster.
So number, how many atoms are
Chika, I cannot actually hear you, but let me help you out with this one. Let's see whether your network will get stronger. The question says, how many atoms are contained in 0.2 moles of nitrogen? Given the Avogadro's number to be 6.0
Contained
times 10
in
to the
zero.
power 20.
It gave us the avocado's constant.
Okay, if 1 mole gives for that Avogadro's number 6.02 times 10 to the power 23, then 0.2 moles should be for X. Then making X the subject of the formula, solve out your 1.20 times 10 to the power 23. This is pretty straightforward. So let's move over to the next one.
Listen.
Can you hear me now?
Yes, I can hear you.
Okay, so let's get to the next one.
Slide number 33.
Yeah.
It said the strength of metallic bonds depend on, I put number of electrons, because it's the number of the electron that will determine the number of valence electrons that will determine how strong that metallic bond is.
Okay.
How did you hear it?
Yeah. Say you put number of valence electrons, right?
Yes.
Yeah. That's what we determine actually. All right. So we have strength of metallic bonds depends on it density of atom, ductility of metal, valency, number of valence electrons, total number of electrons in the atom. It's normally the valence electron that determines whether the atoms are going into covalent, ionic, metallic, or even van der
Yes.
Waals. Valency is what determines it. If you check chemical composition, that's what we did under chemical composition.
Yes.
Okay. So let's go to the next question.
As number 34.
Okay.
When zinc is added to silver nitrate solution, crystals of silver forms on the zinc surface. This indicates that the zinc is I don't know this one. No. I tried it. I don't know what happened.
So read out the question again for me.
I said that when zinc is added to AgNO3 solution, crystals of silver on the zinc surface indicates that the zinc is, I don't know it.
Can you send it as a chart for me?
Okay, so let me send it.
Because I think it's missing on the solution as well.
Yes, it is.
So send it as a chart so that I'll sort it out, then I'll send it back to you. So let's get
Because
to
the thing
35.
itself is hard.
Okay.
Sending
Send it
it
to me.
now.
I'll work on it. Yeah. So get to 35.
I'm coming.
Okay.
I'm trying to send it through Zoom.
Say? Are you still there?
Yes, I'm still here. I've sent it now.
Is it?
So have you seen it? I've sent it.
Okay. Okay. And let's get to 35 then.
Have you seen? I sent it on through Zoom. Have you seen the chat
Okay, let me check.
on this meeting now? I just sent it.
Yeah, send the options as well. Okay.
Okay. But are you seeing it? The question.
Yes, I'm seeing it.
I've sent it.
So the answer is B, reduced.
So how and why?
Okay. No, it's actually A, oxidized, because I told you that okay, let me see. The metals are always reducing agent.
Yeah.
Did I say that? Yeah. Whereas the halogens or the what's it called? The halogens
Or acids.
or the acids are always oxidizing agent.
So zinc is the metal here. AgNO3 solution. Is that
Yeah.
that that is so what type of solution is that? That's an aqueous solution.
You mean the AgNO3, right?
Yes.
Yeah.
So sir, now how do you know that? Is it because of the zinc you just know that the is being reduced?
Yes.
Okay. Should I go to the next one?
Yeah, you can go to the
It said the empirical formula of a compound containing 0.067 mole of copper and 0.066 mole of oxygen is, and they now gave copper as 63.5, oxygen as 16.0.
okay.
So when finding the empirical formula, you do the one that is least between them, and the one that is the smallest there is 0.06. You divide it from both of them, then
Okay.
your answer will be 1 and 1. So you now substitute it into the compound, so it will be copper oxide, CuO. That is B.
Okay.
So did you hear me?
Yeah, I heard you. So first of all, you need to write out the number of moles, isn't it? Already
Yes.
given. So you divide through by
The
the
one
one
that
with
is
the
least.
least. Okay.
So should I go to the next one?
Okay, yeah.
The change in the oxidation state of ion reaction represented by the equation below is, and they gave 2FeCl3 minus plus H2S will give so should I continue?
Yeah, you're on question number what?
Question number
36.
There's that question there. Okay, I've seen it.
36 bar.
Yes. So what is the change of the oxidation state of
State of
ion there?
in the reaction. Okay.
Yes. I put B. I found the oxidation number of ion in FeCl3. I found the oxidation of ion in FeCl3.
So it's changing from what oxidation number to what?
Plus 3.
Your voice is cracking. But actually what was done here is that, you see, this compound, this neutral compound, you equate it to 0 in order to get the oxidation number of the ion alone. So if you make ion the subject of the formula, you get it to be complete. Whereas for this other one, equate to 0 as well. Make ion the subject, you get this. So you can see it changing from plus 3 to plus 2, making option B the right answer.
I said my oxidation state was from plus 3 to plus 2.
So plus 2 bar.
Yes.
Okay, so that's the answer. Let's move. Yeah. But you understood the solving. Did you understand the solving?
Yes, I understand it.
Okay.
But I don't
So,
know where the
huh?
the 2 was in front of ion. No.
The 2.
Yes.
You can see the 2 can cancel out if 2 is here and 2 is here.
So does that happen in chemistry too?
You say?
I said I didn't know it was possible to do that in chemistry too. And can you hear me? Hello.
Yes, I can hear you now.
Did you hear what? Okay. I said I didn't know that happened in chemistry.
The voice is just cracking. Maybe you send me a chat.
Okay, so let's go to the next one.
Okay.
Number 37. Which of the following methods is used to separate blood cells from plasma? This is true separation technique. And they said chromatography is the only technique that is used for separating blood, ink, dyes, and so many more. So my answer is C.
The answer is what?
Did you hear me? C,
No.
because chromatography is used for, for separating blood, inks, and dyes.
Okay, you said your answer is what, C or A?
Ah, C, I chose C.
Huh?
I chose C.
A.
So why is it a centrifugation, not the one for spinning tubes?
Said what?
Then centrifugation, is that not the separation technique that when you spin it, the more dense will be at the
Yeah.
down of the solution and the less dense will be at the upper part?
Yes, that's what centrifugation is.
So sir, is the answer not chromatography? Did you hear me?
Yeah, you said the answer should be what? Chromatography.
Yes, how is it not chromatography?
Okay, say which of the following methods can be used to separate blood cells from plasma? If you use centrifugation, it can separate substances mixed due to their varying viscosity and density. So, such operation like separation of blood cells from plasma is normally done using centrifugation.
Okay, sir.
Is that clear?
Yes, sir. So what about dyes and ink? Is it still
Yeah, for
centrifugation
dyes
or
and
is it
ink,
not?
that one you can use chromatography for that.
Okay.
Yeah.
That number 38.
Okay.
Which of the following statements about ionic radius is correct? Ionic radius increases. Sir, I don't understand this one.
Okay. Oh, in this one, you need to know the effect the nucleus has on the electrons. You know that the nucleus is positively charged because of the charge on the proton. The neutron does not have any charge. So the charge on the proton is the charge of the nucleus, which is positive. Whereas the charge on the electrons revolving around the nucleus, that's on the periphery, the electrons on the shell, they are negatively charged. So that positive charge of the nucleus, as the electrons are revolving around the atom, that positive charge is attracting the negative charge. So it's keeping it uh, keeping it rotating and at the same time attracted towards the center. So the question asks you now, which of the following statement about ionic radius is correct? An ionic radius is simply the distance between the nucleus and the periphery, the valence shell, the distance between the valence shell and the nucleus. So what do you think will happen? So you say, which of the following statement about the ionic radius is correct? Ionic radius A, increase as nuclear charge increase. So does the ionic radius increase as nuclear charge increase? If there is more charge, it's going to drag the valence electron or that very shell to contract it if the charge is very high. So it cannot increase. The ionic radius cannot increase it. It will actually reduce. So option A cannot be the answer. Option B, decreases as nuclear charge increases. That's perfect. Once the charge between them is very strong, they will get attracted. So the radius will get decreased. Option C, decrease as nuclear charge decreases. No. If there is no much charge, they will move apart.
Okay.
Whereas D remains constant, it cannot remain constant. It cannot actually remain constant. So the more the charge, the radius will decrease. The lesser the charge, the radius will increase. Is it clear?
Yes, but
So the charge
okay,
is
the
just brought
lesser the
about
charge.
because it said what?
Okay, so the lesser the charge, the radius will increase. The more the charge, the lesser the radius.
The more the charge, the lesser the radius. Because two of them are oppositely charged. One is positive, one is negative. So they will tend to attract one another. So if the charge is higher, it will continue to attract. And when once that attraction is done, there is compression of the ionic radius. But if the charge is weaker, it
Okay, I
just
now
go out.
understand.
Yeah, it will be bigger. So it will decrease as the nuclear charge increases. Because the charge now, the nucleus is always positive, whereas the valence shell electron is always negative. Do you understand?
Yes, sir.
So if you play this video very well, you will understand more. Because what I just explained is what I did there, except that it's now done
Okay.
in a structural way that you understand.
And it said law of infinite proportion states that a pure samples of the same compound contain the same elements combined in the same proportion by mass. So
Yeah,
that is just law of definite proportion.
that is what.
And they say law of definite proportion.
Are you
Because
working
it
on
gives
question
the
19,
pure
39?
no 40 is
Okay, you did
different
look at
here.
39.
Oh, 39.
There has to be 39 before 40. Check it out.
Analysis of a hydrocarbon shows that it contains 0.93 grams of carbon per gram of the compound. The mole ratio of carbon to hydrogen in the compound is, and they gave H as 1, C as 12. My answer was A because since carbon contains 0.93 grams, so since it's a hydrocarbon, you can just do 1 minus 0.93 grams since it's in grams to get what the hydrogen, the mass of the hydrogen is. Then you can find the empirical formula. You can find the molecular formula, sorry, and you get a mole ratio. So H is equal, the hydrogen will now be equal to 1 minus 0.93. That will give us 0.07. And we have C as 0.93. You divide it by 12. That would be 0.078. Then the hydrogen 0.07 over 1, since hydrogen is 1, to give us 0.07. So now again, you look at the one that is smaller between 0.078 and 0.07 from the hydrogen. It will be 0.07. You divide it, you get 1 1. Answer will be A. So I don't know if you understood what I said.
No, I understood. You did well. That's it. So first of all, just get the gram of hydrogen. So since it's in per gram, so you just subtract 1 gram of this gives you what hydrogen should be. So you divide through by their molecular molar masses. Then use the smallest one to divide through. Then whatever you get becomes the mole ratio, isn't it?
Yes.
Okay. So let's go on. 40.
Now, number 40, the law of definite portion states that pure samples of the same compound contain the same elements combined in same proportion by mass.
So which is the answer?
A.
A. It's very simple. It's one of the three laws that I talked to you about. What are the other two?
Law of conservation of matter.
Law of conservation
Law
and
of
what?
multiple proportion.
Thank you. So it's the three of them. We learned the three of them, isn't it, in our normal class? So there's law of conservation of mass, and that is the last one. You know, that is the option D. Can you notice that the option D is the law of conservation of mass?
Yeah.
That simply states that matter cannot be created nor destroyed, isn't it?
Yeah.
Okay.
That's option D.
Yeah. Let's move
Yes,
forward.
yes. Number 41. What is the relative molecular mass of a compound which has the empirical formula of CH2O?
Okay.
So you write the CH, we're looking for the relative molecular mass, and you give us the empirical formula. So RMM will be equal to CH2O. We now substitute it, so it will be 12 plus 2, because of we have 2 hydrogen atoms plus 16, that will give us 30. The CH2 will be in bracket N because we don't know the number of the molecular formula. So when we add it, we get 30N as the relative molecular formula. And from there, I don't know what to do. Hello.
I can hear you now.
Sir, can you hear me?
Yeah, I'm hearing you now. Come again, please.
Oh, so I said that the CH2O in whose bracket N will equal to the relative molecular mass, which is what we are looking for. After you add it, you get 30 and then they said that which has the empirical formula of CH2O. So with my belief, you now start using 30 times it by 1 to get the option. So you use it as integers. I don't know that one. I didn't understand that one.
Yeah.
Hello.
Yeah.
So I said, why did they start timesing it by 1, timesing by 2, timesing by 3? What if the same option, like when you times it by 4 and 6, were in the same option? when the same question, what would they have done? Like 120 and 180, if they were there, what would they have done? How would they have known the correct answer?
Okay.
Did you hear my question?
Come again, please.
I said that if after timing it by 2 and 3, if the same those answers, like after timing it by 260 and 180 were in the options, how will we know which one to choose?
Okay, let's get the explanation.
Okay. Hello, sir. Hello.
Yes.
You said let me start the explanation.
Did you understand what happened?
No, I didn't hear the I didn't hear the
Can you understand
explanation.
from the explanation?
No, the 30 times 1, I don't know from there.
But you know that the empirical formula times n can give us the
Yes.
molecular formula,
Yes.
or the empirical mass
Hmm?
times n can give us the molecular mass. Do you get that?
Yes.
Okay. So this is the empirical mass.
Yes, sir.
You understand?
Yes.
And the question says, what is the relative molecular mass of a compound with the empirical formula of this?
I understand that one.
Okay. So why we chose from 1, 2, 3, 4, and the rest? When you have a given empirical formula, which is the simplest ratio, the actual formula, which is the
Yes.
molecular formula, can be a ratio that is quite higher than that of the empirical formula or the empirical mass. So when we now assume that, if you assume that is 1, one thing is that the empirical formula has to, or the empirical mass has to be factored in the molecular mass. So it's something that when you multiply by a factor, it should be able to give you a multiple of your empirical formula. So if you do 30 times 1, you cannot get anything here. If you do times 2, you will not still get anything here. Times 3, you will not get. But when you do times 6, you get this.
So yes, what I'm asking, you know, when you do times 4, you get 120. If
Yeah.
120 and 180 were in the were in the options, which one will we now choose? How will we know what to choose?
And you pick 120, but they wouldn't put the two of them for you. You understand?
Okay, sir.
They are not going to put the two
Yeah.
options since they know that it's not going to give you what you're looking for. Because you can actually get a compound with a molecular formula of 180, having an empirical formula of still that CH2O. It's very possible.
Okay, sir. And it says atoms are electrically neutral because I chose but
So
I
atoms are
chose
electrically
B.
neutral because what? You chose B, contain equal number of protons and neutrons. Yeah, that's true. Because they are neutral because they contain the same number of proton and neutron. The protons are positively charged, the neutrons are negatively charged. So once they have equal
Yes.
number, you see the positive and the negative charge will cancel out, making it neutral. But once one is bigger than the other, then you have what we call ions. So ions are not neutral, but normal atoms are always electrically
Yes.
neutral. That's clear, huh?
Yes, sir.
Let's move on.
So, sir, the next one. The, the common salt is used for preserving food. Which of the following properties can be used to determine purity before use? And I chose
Just what?
I chose B.
B, huh?
Yes.
Good. The criteria for purity, we did it already, is melting point, boiling point, chromatography. Okay, the spot on a chromatograph. So if it is a solid, use the melting point. If it's a liquid, use the boiling point. So this one is pretty clear.
Type is gas use chromatography. Or
See?
I said if it's gas, is it chromatography use?
Yeah, it must make a single spot on the chromatograph paper.
Okay, so. And number 44. Which of the following electron configurations represents the transition element chromium? That is 24. After
Which of the
solving
following electron
it,
can be
I
represented?
got because 2 plus, and I looked at the way they are arranged. It has to be S1, 2S, 2P, 3F, 3P, 4, and 3D. Then when I added them, I got 24.
So it's option what?
Cardidium. Hello.
Yeah, I can hear you. So option what did you arrive at?
AA.
Can you come again?
Sir, did you hear me? A.
A, yeah, A is the
A.
answer.
Star number 45. The atomic number of an isotope of hydrogen is equal to its mass number because they don't contain neutrons.
It does not contain neutron, but because it does not contain neutron, that's the answer, Abi. Your voice is dropping. So I think you got the answer already. Total number of an isotope of hydrogen atom is equal to the mass number because it does not contain neutrons. That's true. So get to number 6.
Number 46.
Yeah.
The total number of shared pair of electrons in compound below is. That this one here, they were confusing me too.
Okay.
I said they were confusing me here too.
Okay. So you need to draw it out in order for you to understand. What's the valence electron?
Bond. I chose 10.
Chose what?
How did you hear me? 10.
Yeah.
That is wrong. Okay, so I'm now seeing the way you're doing it.
Can you hear me?
Yes, I saw the way you did it.
Okay, so the way I did it on the screen, but
Yes. Yeah, I saw my method in my own.
okay.
So, the next question.
Okay.
As number 47.
What's 7, but?
Yes, the bonding pair of electrons in hydrogen fluoride molecule is pulled towards chlorine atom because chlorine is more electronegative.
Okay. Yeah, I think you're right.
It has a negative charge, so.
Yeah.
So number 48, the solubility of carbon dioxide in water can be accounted for by van der Waals force because of the weak force.
Solubility of CO in water can be accounted for. Okay. Yeah.
By van der Waals force because of its weak force.
Because of what?
It is a their weak force is.
Okay. So let's keep going.
Number 49. Which of the following properties would not influence electrolytic? D. Catalytic ability. Speed up reactions so they don't affect in electrolytic. Instead, is ionization. Instead, is ionization energy, electronegativity, and electron affinity.
Okay. So which one is out? So which one will not affect it?
And I have no clue. So, Sam, can you hear me?
No, I can't.
Particles in a solid, what do they exhibit?
You say?
I chose A. Particles in a solid exhibit vibrational motion only because
So which one is that? Is that number
in
50?
solid,
Okay.
yes,
Particles in a solid
they're in a
exhibit.
fixed point, so they cannot move randomly or translate. They just vibrate the fixed
Yeah,
point.
they just
They
vibrate
can't move because they
about
are
a
not
fixed point.
gases.
Yeah, that's correct.
Yes.
Okay, you did very well. Nice one.
Thank you, sir.
So we'll work on 2019. Huh?
Yes.
Yeah, let's work on 2019 first. Next, after 2019, work on 2020. Then once we are done, then we'll go back to 2016 and 2017.
Yes, sir.
It's okay that way, huh?
Yes, sir. Please.
Okay, if I'm chance tomorrow Saturday, we'll fix a class so that we'll look at physics.
Okay, sir. Thank
I
you.
know. Yeah. Take care. Thank you.
Bye-bye, sir.
Yeah. Thank you.